everyone, welcome to Learning at 11th Hour. In this video, I'm going to show you how we can represent reciprocal networks in the form of a T network or the T equivalent of a reciprocal network. So if you refer to one of my previous videos where I would have discussed about the Z parameters, I would have taken up this example where I would be computing ZA, ZB and ZC in terms of Z11, Z12, Z21 and Z22. Having given the Z parameters, how do I obtain ZA, ZB and ZC? This is what we're going to see first. So let's get into the video. This kind of a representation which you can see is also called as the global ground based representation. That is because we have a global ground available over here. Now, the other type of representation, which involves the Z parameters, which we've already discussed, Z11, Z12, Z21, and Z22, which actually forms the Z matrix, that would be based on the equation as we know V1 is equal to Z11 I1 plus Z12 I2. V2 is given as Z21 I1 plus Z22 I2. And we can represent this in the port based form as Z11 followed by a current dependent voltage source Z12 I2, this forming port 1, and on port 2 again this would be Z21 I1, this is going to be Z22 for port 2, where the voltage here is V2, the current entering here is I2, coming out from here is also I2, current entering here is I1, coming out is I1, and the voltage here is V1. So this is the port based representation, whereas this is the global ground representation as shown over here. So the T equivalent for a particular network can be obtained only if that network is going to be a reciprocal network. So the condition for reciprocity in terms of the Z parameters can be given as Z12 should be equal to Z21. So when this particular condition is satisfied, then we can say that the circuit is a reciprocal network. So when we have got this, we can get the expression for ZA as Z11 minus Z12, and ZB would be Z22 minus Z21. ZC is going to be Z12, which is also equal to Z21 because this is the T equivalent of a reciprocal network. So these ZA, ZB, and ZC are the T values or the values of the T equivalent of a reciprocal circuit. Let's go on to looking at a numerical example for better understanding. So in this numerical example, we've been given that Z11 is 4S, Z12 is Z21, which is 3S, and Z22 is 9S. Now we've been asked to replace this network N with its equivalent T network. So in order to do that, we need to compute ZA, ZB, and ZC. And this would be our network N. So we know that ZA is going to be Z11 minus Z12. Now, before we go into this, actually, before even we think about replacing this particular network with a T equivalent of it, we have to make sure that this is a reciprocal network. So, looking at the Z parameters given over here, since Z12 is equal to Z21, the condition for reciprocity is satisfied, meaning this is a reciprocal network, and therefore the T equivalent for this network will exist. So it is not necessary that the T equivalent for all networks should be existing. Only for reciprocal networks, we'll have the T equivalent. So now that we made sure that it is a reciprocal network, we can obtain its ZA, ZB, and ZC values. ZB would be given as Z22 minus Z21, ZC as Z12 or Z21 since both are the same. Now just replace these values and we get 4s minus 3s, which is s. Here we get 9s minus 3s, which is 6s. And here we get 3s. So we can now redraw this network in this manner. S here would basically mean that this is an inductive element. So this is S representing ZA. Then we have 6S representing ZB and 3S representing ZC. Now this is clubbed with the rest of the network. So what we can do is we can redraw the rest of the network as it is. This is 12 kilo ohms, and here we have Vs. So now we have replaced the network N with its T equivalent. The next question or the next part of this question is that we have to compute the value of I1 given Vs is equal to cos 1000t. Now in order to do that, we can just find out I as Vs by Z, the total overall Z. So to compute Z, what we can do is we can just look at this as a simple network, a series parallel combination of different elements, and apply the series parallel rule and obtain Z. So looking at this, we see these two are in series. So 6s plus 12. Now, what we're going to assume is the resistors are in kilo ohms and S is in kilo radians per second because that's given in the question. So, we don't have to worry about the K of the resistors. So, I'm just going to say 6S plus 12. This is the resistance of this path or the impedance of this path. This is in parallel with 3S plus K. Sorry, 6. So when I get this, since I say they are both parallel to each other, I can apply the parallel rule to obtain the impedance of this part of the network. So this would be obtained if I call it say R. So R is going to be equal to this. R is given as 6s plus 12 into 3s plus 6 divided by the sum of this, which is 9s plus 18. Now this R is going to be in series with this S. So finally, what is Z going to be? So Z is going to be equal to R plus S. So that's going to be, what is R here? Now let's take 3 common in the denominator, and what we get here is the 3 would get cancelled out. So this would become 3 and this would become 6. And the 3 in the numerator is also going to get cancelled out, the factor 3, and what I would get here is 2 and 4. Now if you look at this, both of these are actually the same, right? So they're common and we can cancel it out. So what I get here is 2s plus 4. Now this has to be added with s because that is what z is. So I'm going to add 2s plus 4, which is the value of r over here. So finally what I get is 3s plus 4 is the equivalent impedance of the entire network. Therefore, the value of I is going to be Vs by Z, which is cos 1000 t divided by 3s plus 4. Now, this can be written in the complex form as 4 plus 3j. And if I write it in the polar representation, this is going to be root over of 4 square plus 3 square angle tan inverse of 3 by 4. So that turns out to be 5 angle 36.9. So I can rewrite this entire term and find out I as I is equal to cos of 1000 t divided by 5 angle 36.9. So this 1 by 5, this actually becomes 0 0.2 because this is the magnitude. So 0 0.2 cos of 1000 t minus 36.9 amps. This is the expression for the current. So in this manner, the first step is to verify that the network is reciprocal, and after that we can represent that particular network with an equivalent T network, and the T parameters or the parameters of the T network can be computed using uh, these expressions which you can see on the left hand side, and the representation of the two networks is either going to be port based, then I'm going to use Z11, 12, 21 and 22, or it's going to be global ground based, and I can obtain this kind of a representation or an equivalent network only if this port based network is reciprocal, which means Z12 should be equal to Z21. So that's all with today's video. I hope you've understood the T equivalent representation of reciprocal networks. Thanks for watching.